Hi, calculus students. Welcome to section 6.4, dot products of vectors. You may or may not have used this in physics, but if you haven't, then this is probably the first time you've heard of this. And you'll be happy to know that it's an easy concept and it's easy calculation. So dot products are useful in higher math. I took linear algebra in college after calculus, and we use dot products a lot as far as talking about force and eigenvectors and moving objects and forces. It's used in physics for forces to find angle measures, and it's used in gaming and art programs too, right? So what the dot product is, let's take a look here, is if you have a vector u with a horizontal component of u1 and a vertical component of u2, notice that this is in component or standard form, and vector v with v1, v2, then u dot v, this is not just a multiplication, this is not u times v, this is a dot that is a little bigger than a multiplication symbol, and you say it u dot v when you're going to find the dot product. And it is simply multiplying the horizontal components of the vectors together and the vertical components of the vectors together and adding them up, right? So u1 v1 plus u2 v2. So let's give it a try, and you'll just find that it's nice and easy calculation. So number two, let's say you've been given u is the vector 2, 1, v is the vector negative 3, 6, w is the vector 0, 5. And so let's do u dot v. So we won't be using w, right? So u dot v would be 2 times negative 3 plus 1 times 6 equals 0. Let's try v dot w, right? So we'll do v dot w, that's negative 3 times 0 plus 6 times 5 equals 30. Let's do a little bit more calculation. How about if we have u dot v plus w, okay? So let's first do u. Let's write u, which is 2, 1, dot, and then I'm just going to do v plus w, and then we'll go ahead and do the dot product. So v plus w, negative 3 plus 0 is negative 3. 6 plus 5 is 11, right? Super easy to add vectors. And now let's do the dot product. Whoop, just tripped on the cord. 2 times negative 3 is negative 6 plus, so again, that was u1, v1 that we multiplied, right, for the dot product. 2 times negative 3 plus 1 times negative 3, and our dot product is a negative 9. Okay, so again, I kept my u, I wrote a vector that was v plus w, and then I did the dot product using the formula here. Let's find the magnitude of u, right? If you remember, that means that for u, we would square 2, square 1, add them up and take the square root, which would be the square root of 5. Okay, now let's do u dot u, where you do the dot product of u with itself, u dot u. Let's write that out. That would be u dot u would be 2 times 2 plus 1 times 1. Notice that you get a 5. Okay, is the dot product of u times, I shouldn't say u, u dot u, u dot u. There we go. Anyway, notice that this u dot u was very close to the magnitude, except it wasn't the square root. So this is pretty cool. I just wanted you to know if you take a vector and dot product it with itself and take the square root, it is equal to the magnitude. So you already know how to find magnitude of a vector. So this is totally optional, but your book will say this. Another way to find the magnitude of a vector is to do u dot product u and take the square root. Let's take a look. So we can also use the dot product. So again, this is not a multiplication. That's a dot product in that numerator. So we can find the angle between two vectors, okay? And that would be inverse cosine, right? That would give you an angle measure. And we tend to answer in degrees because they're easier to read. I'm just going to check, make sure I'm in degree mode. I am. And so this fraction, if you do inverse cosine, will give you the angle between two vectors. So you do u dot b divided by the magnitude of u times the magnitude of b. So let's find the angle between u and b for these different possibilities that we have. Now, there's we will do that below. So find the angle between u and v, and I guess what I meant is the u and v over here, right? So let's go ahead. So our u that we see is 2, 1, and our v, right, is -3 and 6. So let's find the angle between these two vectors. So we already did so that's going to be inverse cosine. And we already did the dot product of u and v, that was a 0 over. Now, obviously, this fraction is going to be 0, right? But let's go ahead and get the magnitude of u times the magnitude of v just for a little practice. So the magnitude of u was the square root of 5, right? And the magnitude of v, let's take a look. I would square 9, right? I would square 6. So I would square -3. Well, I'm just saying silly things today. Let's start fresh. So I would square -3. I would square 6. Add them up, take the square root. This would be 9 plus 36 is 45, and it would be the square root of that. So notice, normally I could put this on my calculator, and you can, inverse cosine is 0, right? But I know where cosine is 0. That happens at 90 degrees, right? And so it turns out then that u and v, if you drew those two vectors, right, in standard form on a graph, that they would be perpendicular to each other at 90 degrees. So here's what I would want you to know. If u dot v equals 0, then the vectors are perpendicular or orthogonal. That is a new word for you. Orthogonal means the exact same definition as perpendicular. It just tended to be in higher math. Like I had mentioned, linear algebra, we said orthogonal a lot. They use the word orthogonal in vectors in physics too. And so just another word for perpendicular. So now if two vectors are not perpendicular or orthogonal, but they have the same slope, right? Which would be v2 divided by v1, right? So if u and v have the same slope, then they're actually parallel. So we're going to find out if vectors are orthogonal or parallel or neither. Okay, so let's try that with these three vectors right here. So notice I have vector u, vector v. So let's look at the first case here, right? So if the dot product of u and v is 0, then the vectors must be perpendicular or orthogonal. Why is that? Because that would make this numerator 0, which would make inverse cosine of 0 90 degrees. Okay, let's do the dot product here. We're pretty good at it now, so we're just going to go ahead and do -3 times 6 is -18, plus 2 times 9 is 18. These two vectors, if you drew them, would be perpendicular. There's a symbol for perpendicular or orthogonal. Okay, let's find the dot product of these two vectors, u and v. This would be -10 plus negative 40. Notice that these vectors are not perpendicular. Let's check their slope. Now, the slope is just the vertical component divided by the horizontal component. Vertical component divided by the horizontal. Why is that? That is because this vector u has an initial point of 0, 0 and a terminal point of 2, 4. So if I did y2 minus y1 over x2 minus x1, I'm just going to have 4 minus 0 over 2 minus 0. I'm just going to have 4 over 2. So the way you find the slope of a vector is just to take its vertical component divided by its horizontal component. So let's see, 4 divided by 2, negative 10 divided by negative 5. Notice both these vectors have a slope of 2, right? These vectors are parallel to each other. Let's check the last u and v. Let's do the dot product. Negative 2 plus a negative 21. These are not perpendicular to each other. Let's check their slopes. 7 over negative 1 and negative 3 over 2 are not the same slopes. So these are neither perpendicular nor parallel. Okay. Before we move on, let's go back up to 3A. Find the angle between U and V. Let's do U and W this time, because I'd like you to see what it looks like when there is an angle that is not 90 degrees between two vectors. So let's do U and W. Okay. I already have my U up there. My W is 0, 5. Okay. Inverse cosine, we're finding the angle between these two vectors. Here we go. The dot product would be a 0 plus 5, right? Would be 5, right? So here's 0 plus 5. Let's get the magnitude. That would be the square root of 5. And the magnitude of this vector, when you square 0, square 5, add them up, take the square root, you're going to get 5. Now, you're welcome to cross these 5s out, but your calculator is fine with doing that, right? So on my calculator, I'm going to do inverse cosine of 1 over the square root of 5. Inverse cosine 1 divided by the square root of 5. And the angle between these two vectors is 63.4. There we go. All right. There's one last problem. I think if you tried on your own in your book, you might have some confusion. So I'm going to erase this board and I'm going to do example number 46. And then we'll be done with the notes for 6-4. Hi, let's do problem number 46 because I'm pretty sure I assigned 45. So 46 says, use vectors to find the angles of this triangle formed by these 3 points, okay? So here's what we're going to do. For each angle, I'm going to turn the sides into vectors in component form and then use this formula to find the angle between them. Of course, you only need to do this twice to find 2 angles because then you could do 180 minus those 2 to get the last one. I'm going to do all 3 angles for practice and to show you that they add up to 180 except for maybe some rounding. So let's first find this angle here at the vertex -3, -4. So I am going to draw 2 vectors that make up this angle here, okay? I'm going to write the vector in component form above and below. So let's take a look. This vector, remember it has to be terminal minus initial, would be 1 minus a -3 is 1 plus 3, which is 4. Vertically, 7 minus a -4 is 7 plus 4 is 11. So this vector here, I wrote in component form is 4, 11. This lower vector here terminal minus initial, 8 minus a negative 3 is 8 plus 3, and 2 minus a negative 4 is 2 plus 4, which is 6, okay? Now to find the angle between these two vectors, I am going to use this formula. Okay, let's see. U dot V, 4 times 11 would be 44, plus 11 times 6 would be 66, over the magnitude, let's see, of this vector would be 16 plus 121, the square root of that. I'm going to do a little math here. The square root of 137 times, and then this vector would be 121 plus 36, 157. This, right, the square root of 157. Okay, let's pop this into our calculator, inverse cosine. It can do the addition in the numerator, inverse cosine. Going to use my alpha y equals 44 plus 66 in the numerator, and then in the denominator, the square root of 137 times the square root of 157. There we go. And that angle would be 41.4 degrees. There we go, 41.4 degrees. Okay, excellent. Let's move on to this top angle. At the vertex 1, 7, just going to do some erasing. There we go. There we go. Let's find this angle. So, initial point, stretch down to a terminal point of -3, -4, initial point of 1, 7, terminal point of 8, 2. Let's write these two vectors in component form, right? So terminal minus initial. -3 minus 1 is a -4. -4 minus 7 is a -11. Notice this is still going to have a magnitude of 137, right? The length has not changed. Let's find out here. Terminal minus initial, 8 minus 1 is 7. 2 minus 7 is 5, -5. There we go. This would be 49 and 25. Just thought I'd figure out the magnitude ahead of time. 74. Let me do a quick check on my math, right? 8 minus 1 is 7. 2 minus 7 is 5. That's 49 and 25. Work here. Okay, think I'm doing okay here. All right, let's find the angle. The dot product would be -4 times -4 times a +7 is a -28, plus -11 times a -5 is a 55. And I will multiply the magnitudes of the square root of 137 and the square root of 74. Let's get that angle measured. Okay, that would be -28 plus 55, and 137 times the square root of 74. Okay, that angle would be 74.4. Again, notice that you could just do 180 to find the last angle. I'm going to go ahead. Boy, do I hope this works, right? Because I've spent some time on this. It does work, but you know, a little bit of math, right? Usually I have you all with me to catch me on my little errors. So let's hope I did a good job today. Let's take a look. Okay. Last angle. Let's find the angle at the vertex 8, 2, right? Let's write these vectors in vertex form. So 1 minus 8 is a negative 7. 7 minus 2 is 5. Notice this is still going to be the same magnitude, the square root of 74. Let's find this vector. That would be negative 3 minus 8 is negative 11. Negative 4 minus 2 is a negative 6. I believe we already found this magnitude to be a 157. Yeah, the square root of 157. All right, inverse cosine of the dot product, negative 7 times negative 11 is 77, plus a negative 30 or minus 30, all over the square root of 74 times the square root of 157. All right, let's go ahead and do that. And let's see, inverse cosine. I have a 77 plus, I'm just going to put minus 30. There we go, 77 minus 30. I have the square root of 74 and 157. All right, let's get that. 64.1. 64.1. All right. How did we do? Let's add these angles up. We have 74.4 plus 64.1 plus 41.4, 179.9, super close to 180, just a little off due to rounding. Thanks for hanging out with me in this section and have a great day.